Hello again. This is Math 2232 coming to you from the College of DuPage. The title of this lecture is Final Exam Content Guidance. As always, please be an attentive learner while watching this video. By way of introduction, I think some congratulations are in order. All of us, did it. All 44 of the learning objectives from the curriculum for 2232 were covered. All of the topical outline topics from the curriculum guide were also covered, including several optional topics. And from your textbook, we covered, as we were supposed to, sections of chapters 5 and 7, and the whole of chapters 6, 8, 10, 11, and the supplemental appendix about the rotation of axes. Lots of work completed well in a compressed and COVID-compromised time. Again, well done. But our work is not finished yet. There is one more big effort required. The final exam. This event is important for all. For some, it will count for 1/3 of your grade. For some, those who do well, it can count for even more. It is mandatory and it is comprehensive. You fail the course if you do not take the final exam. So here we discuss the content. The administration protocols will be similar to those of the midterm and will be discussed elsewhere, not in this video. Here we're going to focus on the content of the exam. What is the exam going to cover? So here's the content summary. There will be 10 numbered problems, but some will have multiple parts. And some of them will come from pre-midterm material. And the ones coming from there, to summarize what I think they are, is evaluating integrals for exact answers, finding exact volumes, finding exact areas between curves, and evaluating parametric derivatives at a point. So those 4 of the 10 numbered problems will come from earlier work, pre-midterm. Some will come from post-midterm material. And those will be testing things such as summing infinite series, areas between curves using polar coordinates, listing the Taylor series for examples, and the first few terms is probably what I will ask for, finding the interval and radius of convergence for power series, identifying conic sections, and estimating the error if we truncate the series. There will also be 2 take-home problems, and these answers will be turned in on the answer sheet, the numerical answers. This is a little bit different than on the midterm, but that's what we're going to be doing here. And these will involve the center of mass, which was something we covered before the midterm, and conic sections rotations, which is something we covered after the midterm. All 12 of these problems will be equally weighted. This is problem number 11. So I have a red curve, a blue curve, and a green curve, which together form a triangle here, whenever you look at the intersections, and the interior is there. So that's the triangle. And what you want to do for this is find the coordinates, the ordered pair, of the center of mass for that enclosed triangle. And you're to assume that the density is uniform. Problem number 12 on your answer sheet will be addressing this problem. And the following questions, I'm talking about these 3 parts, will refer to the equation x squared minus 2xy plus 3y squared equals 1. And as you can see, we do have an xy coordinate here. What is the equation of the conic section in the capital X, capital Y coordinates? where these axes are rotations eliminating the xy term. What are the coordinates of the vertices of this conic section? But I'm asking for the coordinates of the vertices in the lowercase x, lowercase y coordinate system. Read the problems carefully to make sure your answers are correct. And last, what are the coordinates of the foci or foci in the xy coordinate system? And this is lowercase x, lowercase y coordinate system. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now, more than ever, take care of yourself and of each other. We're all in this together. May God bless you all.